Okay, so I hope my slides are visible. My second paper, which I'm presenting today, is called
Okay.
Enhancing Augmented Reality Precision with Leap Motion Technology. And it's been done by another group of my students. When I taught the class last January, that's human-computer interaction. So students who work on this project is called Anubhav, Rayamajhi, Johnny Breeden, Jack Kiefer, John Lee, and myself, Tauheed Khan Muhammad. So today we're going to talk about, let's talk about Leap. I'm going to introduce the topic and then we talk about Leap Motion Controller, which is basically another device to interact with the computer. We'll see how many use cases being used for, then the project which we work on, and then how we'll try to check its efficiency and efficacy and see the results. To begin with, the first thing is it's called, we are working on a project called College Simulator that's called Cup Pong game used in by using created by Leap Motion Controller. So Leap Motion Controller is like a flash drive. The USB stick which we use in the computer is the same size. It's basically a device with which we can hover over our hand, and uh, it can capture and take our movement of my hand. So what this Leap Motion Controller does is a gesture detection device. It can grab and throw. So it can what I could do, I can grab like this thing and we can make a throw. So the way we can play the game in the same situation, we can play around with this device and we can make games. So our goal is to analyze the efficiency of Leap Motion Controller in augmented reality and also test of accuracy of the Leap Motion Controller in detecting and grabbing throw motion. So this is my device look like. If you guys can see this device in the picture, it's basically a very small device. It costs around $200, $250, if I recall correctly. It's been a couple of years since I bought it. I'm pretty sure the price might have reduced. So it has various sensors inside. It basically human interface device. It has infrared detector, haptic device. It has an API application, and it's being used for augmented reality. The use cases where it's been used, there are three use cases which we analyze while we are doing related work. So one of them is called, it's been used for people who are having Parkinson's disease. So they can try to use their limb. So for those who have shaking hands, they can use this device and improve in their upper limb performance. This device would have been used in two groups of 24 participants, and they're traditional experimental groups. And observed that when this device would have been used, it's been observed that this device could be used and it's better for better coordination, speed of movement, and fine dexterity in the dual intervention. It has a low cost, portability, and it's very non-invasive because we don't have to do any kind of surgery or something like that. It's basically a device lying over here, and we are performing experiment on top of it. Second thing is being used for chemistry lab. So in augmented reality, when we perform experiments, some students are naughty and they performing very dangerous experiment and they can try to mix the chemicals. So instead of like putting and giving the students actual chemicals where they can perform experiments which could be harmful to them, maybe a student can make some students step in the class and they try to mix all the chemicals together and make a fire out of it. It's sometimes student does that. So instead of doing that, we can have this device could be used in chemistry lab where they have been giving virtual elements. They can use it and they can put their hands and try to put in test tube and see what are the results coming. So in real time, they can see the changes. It's pretty much like performing the experiment, but eventually we are doing it virtually. Third case is basically this device would have been used for detecting the Arabic sign language. For example, somebody is trying to uh, write Arabic numerals. So what he or she could do, he can use Arabic numerals, for example, by making some gestures, by using their hand, this device can detect it. And then this algorithm would be trained by using algorithms, the naive-Bayes classifier and multi-layer perceptron. These are three case studies which have been done, and we find their usages. This particular device would have been used in three different applications. My game which we develop, it's called Game Simulator, which is based on like cup pong. So if you can see over here in this picture, there are multiple cups towards the end, and we have a hand on the very front. And what is this device does? For example, if you can see my image, like what I'm doing right now, if my hand is like this, I can hold my hand behind this device and I can throw like this. It'll take my gesture. So it'll take, for example, I'm holding the ball, and if I throw the ball, it will go towards the cup. And if the ball goes inside the cup, the person will win the game. So that's the game we developed by using Unity Engine. And this is done by students. And we use leap motion controller to track hand movements. So game mechanics, we have created a game simulator. So leap motion controller, LMC have been used, and we are using our own hands. Used an imported developer package to transfer the sensor information into the application. So when we are using this device, we use the data, raw data of our hand into this device and fed them, and then based on that, we take decisions. We created cup and tables by using Unity. So important models from free websites online, we can create the virtual environment in Unity. We can create a ball and multiple cups to create the environment. Then we have 2D plane, cube, light, and Unity assets. We have imported from the public libraries to create this environment. Then we perform experiments. So this experiment is being given to check the accuracy of this device and efficiency. We have performed experiments. So we have given multiple students as a volunteer, and I was one of the volunteers too. I experimented, like I performed the experiments. So leap motion device is connected to the college simulator, and test use 5 different measurements. We have performed 5 different parameters matrix through which we can say that this device, how accurate it is. One of them is ability to grab. For example, if we can grab the ball, which is grabbing the ball. Ability to throw. So if I'm throwing the ball, is the ball going out from the hand or not? Then hand position. It's been accurately capturing my hand position. If I'm moving right and left, would I have been doing or not? Then we have distant cube was thrown. Then calculate distance from the original point. So these are the 5 metrics through which this experiment would have been performed. Then we get the results. So first result is basically subject 1. That means first volunteer, that is the student 1. He made 17 attempts. Out of which we found that 14 of attempt were successful catches and 8 successful throws, and distance range is 0.13 to 16.9 centimeters. Similarly, the subject 2, we have around 5 different users from which we collect the data. Again, 17 attempts, 16 successful, 11 successful throws. That means the ball goes into the cup, and then distance range we calculated 0.39 to 5.75. And we have third one, we give 30 attempts, 29 successful, and one of them is unsuccessful, 26 successful throws, and distance range is 0.30 to 27.5. Then we have 4, it performed 25 times, experiment is performed. So we have given a good number of chances to everybody so that we can have a very holistic data, so that after that we can claim how accurate this device is. So we perform it multiple times. We found 23 times successful, 15 times throw is successful, and then distance range is 2 centimeter to 7.3. The 5th subject is having 14 attempts, 10 successful, 4 of them are unsuccessful, 71% accurate, 7 successful throws, and distance range would be 0.11 to 5.9. So overall results showing that if the slower the movement, it is the better. The accuracy is approximately 81.1%. And throw test is approximately 73%. But this is basically type of game. We could not say it's basically a pure accuracy because, for example, somebody is playing a video game. If he does not know how to play the video game, initially he will be lose all the time. But once he get pro in it, once he keep playing and playing and playing and again, he'll find that he will improve over the time. So this accuracy could be improved. But the grab test is basically the accuracy of the device. This is what we are more concerned about. Then we are talking about hand position, how comfort zone it is, and the accuracy. So that's pretty much all about what my research is. It has, in summary, we have the ease of use of 75% of the use, find it to be intuitive and easy to use. We don't have to explain them what you have to do with this device. They are basically, with it itself, they can find out, they can explore that what exactly needs to be done. Its portability, it's very easy. It's like a very small device, as I mentioned, like a size of a USB stick. It's better than any other output device. It has issues. It has detection issues. For example, the computer which is being connected with, if I switch back and forth, it will sometimes not detect it. So it needs a little while to connect to a software and pop up the application. And then the precision is also one of the okay ones. So that's lead to the second end of my second presentation. I'm more than happy to answer any of your questions.
Thank you very much. Fascinating, Mr. Han. Your research opens up exciting possibilities for the future of augmented reality. We better understood the advantages and issues of the leap motion technology. I would like to ask again, does anyone have a question for the presenter? I couldn't see the conference. I don't know the other guests, but if no,
You're welcome.
thank you very much again.